Circular motion. Period and frequency, the basics of circular motion. Then we'll define what uniform circular motion is, and then centripetal acceleration, centripetal force, and finally some problems on vertical uniform circular motion and horizontal uniform circular motion. Period and frequency. In this unit, we will study the motion of objects traveling in circular paths. Previous units considered objects at rest and objects moving in straight or linear paths. One of the main differences between linear and circular motion is that circular motion repeats. For example, instead of measuring the total time it takes for an object to get from point A to point B, the time it takes to go around one circle is measured. And, as you can see here, if you keep going, the motion repeats. Period. The time it takes for an object to complete one trip around a circular path is called its period. So that's from here right to here. The symbol for period is capital T. Periods are measured in units of time. We will usually use seconds. The period of the second hand on the stopwatch, that's the red arrow, is 60 seconds. It is sped up here for illustration. Often it is more practical to measure the time t that it takes for an object to make a number of trips, little n, around a circular path. In that case, the period is calculated as t is equal to time over number of trips. Let's work an example. A runner completes 6 laps around a circular track in 648 seconds. What is the period of the runner's motion? Answer on next slide. We write our givens. N is equal to 6, time is equal to 648 seconds, and there'll be many different names for this. You could call it laps, revolutions, turns around a circle, and as long as you have a number in front of it, that's going to be this little n here. So the period is time over n, put in the givens, and we get the period is 108 seconds. Another useful measurement in circular motion is how often a cycle repeats. All right, that's also another name for laps or turns around a circle. The number of cycles completed in an amount of time is called the frequency. The symbol for frequency is F, and the units usually used to measure it are hertz. 1 hertz equals 1 over second, or second inverse. The period and frequency of the flashing lights are indicated over here. Again, it is often more practical to measure the time it takes for an object to make a number of revolutions. Also, you'll get a more accurate answer. In that case, the frequency can be found from this, number of revolutions over time. A common example of frequency can be seen on the dashboard of a car, indicating revolutions, there's another term for making one cycle, per minute, or RPM of the engine crankshaft. Perhaps you notice this, but period is the inverse of frequency. Also, of course, frequency would then be the inverse of period. A motor turns 120 times, and that's going to be n, in 4 seconds. What is the frequency of its motion, and what is its period? Our givens are right here. N is equal to 120. Frequency is n over t. So we put 120 over 4 seconds, and we get 30 hertz, or 30 per second. Right? See how seconds is in the denominator? And the period then, we can either use t over n, or we can just do 1 over the frequency, the inverse of frequency. So 1 over 30 hertz, 0.33 seconds. And since this is seconds down here in the denominator, seconds inverse, that's also equal to just seconds. A pendulum swings with a frequency of 0.25 hertz. How long will it take to complete 20 cycles? And what is its period? Start with the frequency formula, but we're looking for time, t. So we rearrange the equation, so it's t equals n over f. Substitute in 20 for n, 0.25 for hertz, and we get a time of 80 seconds. And then to find the period, we just take the inverse of the frequency. So it's 1 over 0.25 hertz, or 4 seconds.